Hello student, next topic dimension and dimension analysis. So in previous lecture we have seen fundamental quantities, fundamental units. So with their units we can derive the dimension. So to express any quantity we require three fundamental quantities and three fundamental units, that is length, mass and time. So, as mentioned earlier, a derived physical quantity can be expressed in terms of some combination of seven or fundamental quantities. And for our convenience, the basic quantities are represented by symbol L, capital L for length, capital M for mass, capital T for time, capital K for temperature, I capital for current, C capital for luminous intensity, and mole, okay, in terms of small letters it is for amount of mass. Now the dimensions of physical quantities are the powers to which the concerned fundamental units must be raised in order to obtain the unit of the given physical quantity. So we can raise this physical quantity, okay, with respect to their particular quantities. Now when we represent any derived quantity with appropriate powers of symbols of fundamental quantities, then such an expression is called dimensional formula. So this dimension formula is expressed by square bracket and no commas is written in between any of the space. So here you can see this, okay. Suppose if we consider one quantity, that is velocity. So formula of velocity, displacement upon time, and dimension of velocity is nothing but what? L upon t, because displacement is in meter and we know that, okay, we use, okay, for meter length, and t is a time, so its dimension will be L m t. So it has only two terms, L and t, so that L1 m0 and t minus 1. Then second, dimensional formula of velocity gradient. Velocity gradient is nothing but what? Velocity upon distance. So dimension of velocity is what? So just previous we have calculated dimension, that is L t inverse or t minus 1, okay. So you can ask me a question, why m is not written? Because m is 0, okay, so you can neglect it. So dimension of velocity gradient L t inverse and upon L, so L will cancel out, so it will be what? L0 m0 and t minus 1. Similarly for dimension formula for charge. So what is charge? Current into time. So dimension formula of charge is what? I into t. So remaining terms will be 0, L0, M0, T1 and I1. So in this way you can write the dimension. So in given bracket, okay, some formulas are given, okay. Density, mass upon volume, okay. So volume is nothing but what? Meter cube, okay. So you can see here meter cube, so that we have taken it is in the denominator. If you take it on numerator, it will be L minus 3, okay, and it will be L minus 3 m1, because for meter mass m1 t0 and L minus 3. Now about second, acceleration velocity upon time, okay. So meter per second square, so it will be L1 t minus 2. Then momentum, mass into velocity, so it will be kilogram meter per second, so m1 L1 and t also minus 1. Then next one, force, mass into acceleration, so here you can write that, okay, kilogram meter per second square, so that L1 m1 and t minus 2. Then next, impulse, force into time, so you have to write dimension of force and again time, so L1 m1 t minus 1, okay, minus 2 plus 1, it will be minus 1. Then about work, okay, unit is joule, again L2 m1 t minus 2. Kinetic energy, again it is joule, okay, so it will be L2 m1 t minus 2. Pressure, force upon area, okay, so it will be L minus 1 m1 and t minus 2. In this way you can calculate the dimension, okay, which is very easy way. Now we have to see it's about second part, that is dimensional analysis. So when we will see about analysis, we have to derive some terms. So let us see it one by one method. Okay. Now first, to check the correctness of physical equation. So what is correctness? Correctness means what? Whatever be the terms on LHS and RHS, whether it is correct or not. Okay, that we have to correct, or that we have to check. So in any equation relating different physical quantities, if the dimensions of all terms on both the sides are same, then that equation is said to be dimensionally correct. If LHS is equal to RHS, then that term is dimensionally correct. This is called the principle of homogeneity of the dimension. So consider first equation of motion. This is kinematical equations of motion. So see here, V equal to U plus AT. So dimension of LHS are what? LHS only V. Okay. Velocity, so it will be L t minus 1. For about U, that is also velocity, L into t minus 1. For A into t, it will be L t minus 2, and into t it will be L t minus 1. So if you write the dimension of RHS, it will be L t minus 1 plus L t minus 1. So all these dimensions are what? Same. So LHS is equal to RHS. As the dimension of LHS and RHS are same, then the given equation is dimensionally correct equation. Okay, so in this way we can check the correctness of these dimensions. Now, second, to establish the relationship between related physical quantities. So we have to consider one formula. In next year you have this formula, okay, period of pendulum. So all of you have seen the pendulum. So it has some length L, and it is depend upon its acceleration due to gravity, that is small g. So period t of oscillation of simple pendulum depends on length L and acceleration due to gravity g. So let us derive the relation between t, L and g, where suppose we have to consider first t is proportional to LA. Okay, you can notice here we have to raise the power L raised to A. Okay, then G raised to B. Okay, again T is proportional to G raised to the B. So T is equal to K L raised to A G raised to B, where K is a constant of proportionality and K is what? Dimensionless quantity, which is constant, where A and B are rational numbers. Okay, whatever it may be numbers. Now equating the dimensions on both the sides, what will happen? Look at here. So dimension of t is nothing but what? Period is in second. So its dimension will be what? M0 L0 T1, which is equal to K into L raised to 1 into A. Now here write L t raised to minus 2 into power B. So if you multiply it, it will be L A L B. So it will be L A plus B and t to the power minus 2B. So if you equate this term, okay, it will be L0 T1 is equal to K into L raised to A plus B t raised to minus 2B. Now we have to compare each power now, okay, for mass, for length and for time. Suppose for length, if you consider both the sides power, okay, length power will be what? Here L raised to A plus B, which is equal to 0 on LHS. So A plus B equal to 0, therefore A equal to minus B. Is it? Now L equal to minus B, that is about for A plus B. Now for t, if you consider for time, t1 is equal to t to the power minus 2b. So it will be minus 2b is equal to 1. So b raised to minus half. It will be minus 1 by 2. So a equal to minus b. Okay, from previous equation we can consider a equal to minus b. So again it will be minus of minus half. Then it will be minus minus plus. So what is value of A? A equal to half. Okay, what is value of B? B equal to minus half. So if any term is in the terms of half, so it will be bracket to the power half also, or we can write in square root. So here, therefore t equal to k under root L upon G. Why L upon G? Because L raised to half and G raised to the minus half. So values of k is determined experimentally and it is found to be therefore t equal to 2 pi under root L upon G. So in this way you can calculate t equal to under root L upon G. So in this way you can build up the relation between the related physical quantities. Okay, see here what is topic, that is to establish the relation between the related physical quantities. So which are physical quantities here? T and L and G. Now next one, that is to find the conversion factor between the units of same physical quantity in two different systems of units. So which two different systems? So in previous lectures or first lecture we have seen these two different systems, that is CGS and MKS. Okay, or MKS we use at a SI unit. So let us use the dimension analysis to determine the conversion factor between the joule, okay, that is SI unit of work is joule, and erg. Okay, erg is a CGS unit of joule. So 1 joule is equal to 10 raised to 7. Okay, see at the end. So we have to prove this term 1 joule equal to 10 raised to 7 erg. So first of all we consider 1 joule equal to 10 raised to x erg. We don't know the value. Now what we are going to do, we are going to write dimensions of work on both the sides. So what is dimension of work? It will be m1 L2 T minus 2. And if you put the values in these dimensions for this equation, 1 joule equal to x raised to erg. So what is that value? m1 L1 T1. For suffix we have to consider on right hand side, x into m2 L2 T2, and whatever be the dimension that we have to write, so it will be m1 L2 T minus 2. Then on right hand side m1 L2 T minus 2. Now take this right hand side term, on the left hand side it will be denominator. So x is equal to m1 upon m2 bracket to the power half, then L1 upon L2 bracket to the power 2, and T1 upon T2 bracket to the power minus 2. So where suffix 1 indices SI units and suffix 2 indices for CGS unit. Whatever suffix we have taken, that indices unit, 1 for SI unit and 2 for CGS unit. Now in SI units, L, M and T are expressed in what? Meter, kilogram and second. So MK is for what? Meter, kilogram, second, and CGS for centimeter, gram, second. So it will be L, M, T are represented in centimeter, gram and second. So X is equal to what? So we see here M1, that is kilogram, M2 which is in gram because it is in CGS. Then about second term, meter upon centimeter, length in meter about MKS and centimeter about CGS. Then second, it is same for both the units MKS and CGS. Or X is equal to what? What is meant by kilo? Kilo stands for 10 to the power 3. So it will be 10 to the power 3, gram upon gram. So this will cancel out. And here 1 meter is equal to 100 centimeter. Again centimeter will cancel out. So here remaining term will be what? 100 centimeter. Centimeter cancel out. Bracket to the power 2. So 100 raised to 2, it is nothing but what? 100 raised to 4. Means what? 10 to the power 4 which we can write. And here remaining term is what? Minus 1 raised to minus, so it will be 1. Is it? And about here 10 to the power 3. So 10 raised to 3 into 10 raised to 4. So whatever be the powers to the 10, that powers will be added or subtracted. So it will be 3 plus 4 is equal to 7. So therefore 1 joule is equal to the 10 raised to 7 erg. So in this way you can calculate the conversion factor between the SI unit of the same physical quantity in different systems of unit. Okay. Below that one example is also given. Okay, you can solve this example. Okay, so that you will realize what is the relation between them. Now if you want to see the limitations, that limitations also you can see here. Okay, what are the limitations of dimension analysis? The values of dimensionless constant can be obtained with the help of experiments only. Okay, so constant only you can calculate on the basis of experiment. Then dimension analysis cannot be used to derive the relation involving trigonometry, exponential and logarithmic functions, as these quantities are dimensionless. Then this method is not useful if constant of proportionality is not dimensionless quantity. Okay, if any quantity dimensionless, it is not useful. For example, gravitational force between 2 point masses is directly proportional to the product of two masses and inversely proportional to the square of distance between them. So F equal to m1 m2 upon r square. So F equal to capital G m1 m2 upon r square, where constant of proportionality, that is G. So G is not dimensionless. Thus earlier method will not work. Okay, so method is not useful if constant of proportionality is not a dimensionless quantity. And then if correct equation contains some more terms of the same dimension, it is not possible to know about their presence using dimension equation. For example, okay, if you consider about the with the symbols of equation S is equal to half at square, it is dimensionally correct. However, the complete equation is what? S is equal to ut plus half at square, that is also dimensionally correct. Okay, because S is in meter, ut, that is also you will get, if you calculate that dimension, okay, meter per second, then second will cancel out. Okay, so that you can write these terms also. Okay, it contains some more terms also. Okay, so if you look here three terms are there: S, then ut, then plus half at square. Okay, and all these three are dimensionally correct, so that this is also one required term. Fine. If anyone is not dimensionally correct, then still it is dimensionally incorrect equation. Fine. Okay, thank you students.